All right, so we're going to keep on looking at histograms today, and I'm going to go through a few more examples here. So at the moment, we get given, remember, a histogram is on numerical continuous data. But anyway, or mainly numerical. So you can see in this example the number of phones per thousand, per thousand people. So that's pretty much numerical, but anyway, we've done a histogram on it. Now we can also have here, we've got another one over here as well, and they've got secondary school attendance rates. So if you notice that data is a percentage, and they can often do things to annoy you, like where they're putting a percentage data value, and but it's still over here. This is still just a number of frequency. So anyway, we get these histograms, and we're often asked to comment on once we've set it up, what does this data tell you? So when you comment or make a report on this, what you have to comment on is three things: is generally the shape, the center, and then also they might say the spread. So here, the shape is like what we said. We said, all right, this is positive skewed, yeah? The big tower's at the start and it's skews down. If you can't remember, you just go to your reference sheet and refer to it. That's fine. You'll get used to it and then you'll know. So that one's positive skew, no outliers. Now, the other one, now when we want to locate the center is where we probably, remember I said, it's best to go and use the median, because the median's not affected by extreme values. All right, so what I'm going to show you is actually how you can find the median of a histogram itself. Like, you don't have the data, you just have the histogram. So you guys don't have this page, but I'm going to... All right, so this question one, the percentage of countries with secondary school rates of 55% or smaller. So 55 is actually up here. So what you're going to do is this is the number of countries. Now in total there was 200 countries. Okay, so when they ask what's the percentage, remember I said you always go the amount over the total times 100. So here we're going to have, it's going to be out of the 200 countries times 100. Now we're looking at how many were smaller than 55. So we've got to add these all up. So, we might say that's 32. This one might be 18, 20. I'm just making these up. 15 and maybe 9. So what do they all add up to? That's 24, 44. What are we up to? 62 and 94. So 94 times 100. So it's probably going to be that 46%. Yeah? Okay. So, and there's that one. So I've got, this is that example there, and I'm going to go through it. So we can describe the shape and note if there's any outliers. So all we have to write here is positive skewed. Okay, so that's fine. So this part B I'm going to do here is you're trying to find the center. So the center, I've told you, is when you're going to quote the median. So what we have to remember is the median is where we've got that rule that we had where you can find, so we can find the median at n plus 1 divided by 2 position. Okay, so then what we've got to do is n is how much data they collected, and generally they will tell you in the blurb of the question. And you can see they said the histogram opposite shows the distribution of the number of phones per 1,000 people in 85 countries. So n equals 85. So you'd have 85 pieces of data in your list that went into the calculator to create this histogram. So therefore, if I'm finding the median of this one, I'm going to go 85 plus 1 divided by 2. So that's going to be the 43rd data value. Does this make sense? Do you get what I mean? If it was in order from smallest to largest, we'd have to go get the 43rd. So what you can do, you're trying to find where did that 43rd one occur. So what you do is you count up the frequency here until you get up to the 43rd one. So if we have a look here, I'm going to say that this one's roughly, I'm going to say 32. There was 32 in there, yeah? So between 0 and 170, we had 32 of those values. Does that make sense? So then if I add this guy on here, what do we reckon that is? About, I don't know, 16 or something? 17? We'll add 17. So if we add 17, our running total is what? 49. So that means the median must have occurred somewhere in that slot, that category. So the median occurred in this category. So when you go to write about where the centre is, you can just say the data has a median at, now I'm just going to say it was 170 to 340 number of phones per 1,000, yeah? So that was the median per 1,000 people. Okay, so there's how you can get the median. Now you can do dot point. Don't worry, I don't want all the dribble. We don't look for it. Half the time we're just scanning to find that you wrote the median and the stat. So, you know, you can, if you have to either just answer it like this, or if you write a report, it's back there on that example. Now, estimate the spread. Now, here we'll do the last one. The spread is when you talk about the range, yeah? So we're going to talk about the range. So the range is just the maximum minus the minimum. So here, when they say estimate, because we just know what the end category is, isn't it? So I'm going to say roughly the maximum number was that last one that they gave us there. Oops, sorry. Which was 1,020. And what's our minimum? What does our lowest one say? Yeah, we hope, they've said 0. So there's our range. You just say that it ranges from 0 to, the range is 1,020, okay? So they said estimate because we don't really know exactly, but we're just going to say because of that category, they put it up there. It's somewhere up there. Okay. So looking at this one, the histogram shows the distribution of population size of 48 countries. So up here, they're giving you always the end. So 48 countries were surveyed and they found their population size. Just be careful because the answer would be millions. So the number of countries with a population size between 5 million and 20 million. So that is all these guys here. So you would add up all those frequencies. So what have we got? We've got 23 there, 11 there, 4 and what's that? 2? So 6, 17, 20, 40. What? Oh, did I add them wrong?
The first column isn't.
Oh, the first one isn't in it. Good. Thank you. So what did we get? 17? No? Yeah. So 17. So be careful. It was from here to here. Excellent. So what would say the shape of this one would be? We've got it all at the top and then it spans out. So what's that? And what's this guy out here? Yeah, so we're going to say this is positive skewed with an outlier. So the following information uses for 1 and 2. So this is be really careful because you might get to question 2 and need some of this. So a group of students was given a comprehension test and each received a mark out of 50. The results are shown in the histogram. So just take note, this is just a frequency, not a percentage. Okay, the percentage of students who received a mark of at least 30 is. So we need to know of at least 30. So 30 was up to here. So you would add all those up, which is 15, 14, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, 127, 128, 1 what's that one? 8, is it? 4 and 1. So you add all them up, but you also needed to know they want the percentage. So remember, the percentage is the amount over the total times 100. So if we go through this, the amount we've got is in the blue, which was how much? So we've got 5, 12, 24. What? Who's at least 30? Oh yeah, good. Anyway, sorry, we want this way. So let's go the amount. So how many was that? That was 12, 7. Oh, I'm struggling to read this. 4 and 3. So what's that? That's 14, 26 out of, now we had to get the total. How many was there in total? That's weird. All right, so be careful. That was not it was a score out of 50. It didn't tell you that there were 50 kids. You had to count them all up. And what would the median mark be? Now, you've said that there was total. We now know n equals 80. So the median would be found at n plus 1 divided by 2. So it's going to be at 40.5. So when you count through, where do you get to the 40.5 mark, which was, I think, in this one? Wait a minute, we've got 5, 12, 24, what did I say, 38. So it was in this one, yeah? So what category is that? That's between 25 and 30. So which one's between 25 and 30? There's only one answer there, and that would be that one. The histogram below shows the weights and distributions of 143 different bird species living in a small zoo. Okay, describe the shape of the histogram and note the number of possible outliers. So we just would say this one's positive skewed, yeah, with outliers. And then we'd say quote the positive outlier. These guys look like outliers out here. And if you look at the frequency of them, what do they look like? About 5 or 6, yeah? And just say approximately 6 outliers. That one, no, you won't get one that dubious. This is obviously a trial exam. All right. What percentage of these birds weigh less than 1,000 grams? So 1,000 is here. So now up here they told me N was 143. And up there, that tower, less than 1,000 grams. What's that? That's 102, is it? I think so. Yeah. So remember, percentage. Percentage would be an amount over total times 100. So we're going to say 102 over the total, which was 143 times 100. And what does that percentage? Yes? Okay. Let's have a look. A number of families were surveyed to see how many beans they consumed in 3-month period. The results were shown. The percentage of these families who consumed 15 cans of beans in 3 months is closest to who consumed more, than 15. So if you look up the more than 15, was this got 25 plus 10, which is 35 plus 5, which is 40. So there was 40 of them. Now we need a percentage. So we need the amount over the total times 100 again. So the amount was 40 over, now how much was there in total? So we had 40 plus 30, that's 70, plus 15, that's 85, plus 5 is 90, and then times by 100. So what does that end up being? A bit less than 44. The histogram shows the distribution of marks obtained by 52 students. So they're nice, they've given us the 52 there. The shape of this distribution, what's this one? Yeah, negative skewed. The median mark for this is, so remember the median's going to be found at n plus 1 divided by 2. So 52 plus 1 divided by 2. So it's going to be the 26.5. Now, you can go either way. It can go 26.5 in that way, or you can go from the other end, the 26.5. You're going to hit the same spot. The median is the center. Why do you reckon I'm going to go from the other end? Because those columns are bigger. It's just going to get me there quicker. Does that make sense? And I don't want to add all these little ones up. So what are we saying this one is 8. And what do I want to get to? 26. So 8 plus 9, that's what, 17, plus another 8, which is 25. Is that right? Plus another 7. What do we have to... Oh, no. Oh, yeah. So we're definitely getting into this one, aren't we? Because I only had to get to 26.5. So what are we going to say? Greater than 30 and less than 35. C. All right, so we're going to talk about when histograms have a log scale. If you saw back, so when you have a log scale, a log is it's the way of reducing, compacting the numbers. Because what happens is we either have really a big range of like a really tiny number and a really big number. And so when we put it on the histogram, it's stretching out this data greatly. So if you have a look here, probably down here is a good example. So it said this was the body weight, and sorry, they've cut off the info, but this was the body weight of all these animals in a zoo, okay? So if you think about it, see up here, this was in kilograms, so we had some elephant or something up in the huge amount of, I don't even know if it was kilograms, whatever they were measuring. And then, obviously, where are all your other animals? Remember, at the zoo, you've got like a spider that weighs bubbles of nothing and all that. So there's great variance, isn't there? So you can see we've got all these animals fall into the lowest category, and then you've got this one out here. Now, if we take that same data and we do a log scale, you can see it changes the histogram. So what a log scale means, see how here when you have a -2 or here, all that means is the actual number is 10 to the power of -2. So 10 to the power of -2 is actually 0.01, isn't it? So and then 10 to the power of -1. So you start to reduce, it makes the categories a bit more usable, and then you can see a bit better how the data is actually distributed across there. So what you have to do is if you have a log of, so if they tell you the log number, and it's always log 10, if they say the log 10 number is equals 3, what it actually is, so what the actual number is 10 to the power of 3, which is 1,000, isn't it? Yeah? So it's a way of condensing that scale in there. So here, if you have to go from a number to a log, so say I wanted to go from 1,000 to the log number, what you got to do in your calculator is you'd go log 10 1,000, and you'll end up with 3. And if you have to go back the other way, there's that. Don't worry too much. It's mainly that scale. So I'll go through a few with you, some questions and a bit more sense. Don't overcomplicate it. So here it says find the log of 45. So in the calculator, you just do log 10. It's in the blue in your calculator, and you do 45 and you get here. So 45 as a log number is actually 1.65 whatever. So if I had a histogram down here and had a log scale, a log 10 scale, and you might have -1, 0, 1, and 2. 45, the number 45, it falls into here. Here, isn't it? Number 45, it has a log scale of 1.65. So it actually falls in that category. And then if you have to convert here, they've said that actually has a log number, so it would be up here, falls somewhere in there. If you need to that, you just go 10 to the power of 2.7, and you found that would be 500. So the weight of 500 or something, or if it would be in there. All right, you don't have to worry too much, just know how to flick it around, but I'm going to show you with the histograms. It's mainly reading the histogram, okay? So let's do some of these questions. So here we have we've got a histogram that shows the weights of 27 animal species plotted on a log scale. What body weight is represented by the number of 4? So remember, 4 on a log scale just means 10 to the power of 4. You just do the number 10 and whatever log number it is to the power of that. And so that actually equals 10,000. Did it say kilograms or whatever? It said kilograms, yeah, 10,000 kilograms. So how many of these animals have a weight more than 10,000? So what you're looking for, 10,000 equals a log of 4. So you look for a log of 4 and anything more than that. And then we look, this is a percentage, so it says how many. So it looks like 8%. So here, 8%, and there was 27, n equals 27, that was total. So 8% of the 27, so there was 2.16, so 2 animals had a body weight more than 10,000. So down here, I've shown you how to do it. The weight of a cat is 3.3 kilos. Use your calculator to determine. So we just go in your calc, just put log 10, and then you put the number 3.3, and what you get is 0.52. So the cat is in here. This is where the cat is. It's somewhere between, oh no, sorry, it's this, no, it's in there. The cat's in that category. What's 10 to the power of 1? What can you tell me about 10 to the power of 1? It's 10, isn't it? So this number here is 10. So you know the cat would be less than 10 kilograms. If we had a cat that's more than 10 kilograms, we got in trouble. All right, so here, remember we did the 143 birds before? And we had that histogram? Because it's stupid, because we've got some birds that weigh a lot. We've got, so say like our emu, our ostrich, I don't know how heavy they get. What do they get? About 80 kilos or maybe. Some of them. So you've got them being huge. This might have been in grams. It was in grams. So you've got these huge heavy weights. Even I think a big, what is it, those albatross or whatever, gonna weigh, big muscly birds gonna weigh a lot. And then you've got your little whatever. Most of them are gonna be down here in the featherweight, in the lighter weight things. So that was a good one. That it was a bit stupid. We would have put that in a log scale. So, Okay, so the histogram 2 below shows the weight and distribution of see, they've now changed this. See how they've changed that? It was the same, the 143 birds. How many birds weigh between 10 and 100 grams? So this is an actual number. Now, a log scale, this is a log. So remember 10 to the power of, this actually means 10 to the power of 1, which is 10. So what I do, and I think you should do, when you get these log scales, just go and write what they actually are. So that's actually 10 to the power of 3, which actually means 1,000. So then you'll know, and this one actually means 100, because it's 10 to the power of 2. So they want who between 10 and 100. So that's this category. So they want how many? So what is it, 37? Yeah? I've read off that tower. Just change, when you get these log scales, change the number underneath to the actual number and then answer the questions. You'll be fine.